Good morning, guys. We're moving into chapter 4, where we're going to be comparing a lot of the quadratics, where we're looking at the vertex form and the standard form. So chapter 3, we looked at the standard form and factored form. This unit, we're going to be focusing more on the vertex form. The nice part about this chapter is because we've graphed it earlier in the year, hopefully some of it will be a little bit more familiar. So today we're specifically looking at the vertex form and how to get to it. So really, we're going to be expanding our standard form to get to our factored form. So let's just do a little refresh from chapter 3. I know this is a little bit overwhelming. Let's go over here. This is better. So last unit, we moved from standard form, and if we factored it, we got into our factored form. Now, we liked our factored form because we could get our x-intercepts from there by looking at the values here and here. If we had factored form and we needed to get back to standard form, we would expand and simplify, use FOIL or a distributive property to get up to here. This unit, specifically today, we're going to be looking at our factored form. And in order to get from factored form all the way to standard form, we can take this, we can expand and simplify and get to our standard form. Tomorrow, we're going to look at how to get all the way back up. It's going to be completing the square. You might remember it from grade 10, so we're just going to spend tomorrow reviewing something from grade 10. But today, we are just expanding and simplifying to get to our standard form. A few refreshers. This is your vertex form up here. H and K are your vertex. Standard form is this guy right here. Our C value would be our Y-intercept. And to be honest, there's not much else that we really need to know. Your vertex is the highest or lowest point of a parabola. I think we can move on to from the tiny details. So let's look at an example if we need to expand and simplify. If I have something like this, this is in vertex form, and we need to factor it as we need to expand it in order to get to standard form, right? Because the question wants it in standard form. So there we go. We are going to use our BEDMAS to expand our exponents first. Then we are going to multiply everything by 2, and then we're going to add the 1 at the end. So I'm going to have x minus 3 times x minus 3, and then the plus 1 at the back. So all I've done is this squared means that this bracket is written out twice, so I write it twice. Now we can use our FOIL. I'm going to take x, and I'm going to multiply it by x. And then I'm going to take x times 3 times negative 3, and then negative 3 times x, and negative 3 times negative 3. So let's see what we get here. I'm going to keep my 2 because I haven't used it at all yet. I'm just keeping it so I don't have to move it. Then we're going to be left with x squared. Oh, hold on a second. There we go. There we go. Loves doing that to me. There we go. So x times x is x squared. X times negative 3 is negative 3x. Then negative 3 times x is also negative 3x, and negative 3 times negative 3 is plus 9. I'm going to close my bracket, right? I'm keeping my brackets, and then I'm going to keep the plus 1 at the back because I haven't touched it yet. I'm going to simplify these two terms in the middle. Actually, so just to make things go a little bit faster, we're just going to copy and paste. And negative 3x minus 3x. Remember, you're looking at the signs all the time. Negative 3 minus 3 is negative 6. Okay. And now I've got this part. I want to take the 2, and I'm going to distribute the 2 now into the brackets because I can't simplify anything else in here anymore. So I'm just going to take my 2 and distribute it. Oops. And 2 times x squared is 2x squared. 2 times negative 6 is negative 12. And 2 times 9 is 18. I still have this plus 1 at the back. And now I can just collect the 2 terms at the end, the 2 constant terms with no variables, and 18 plus 1 is 19. Okay, and I have to stop here. There's no other terms that I can combine. All of the terms are different terms or unlike terms, so we're going to finish here. And I've taken something in vertex form, and I've expanded it to something in standard form. take my word on this, if I were to take this equation and this one and I graphed them, you would get the same parabola. It's the exact same quadratic. It's just looks, the equation just looks a little different, but the graph is the same, or the quadratic is the same. Okay, it's just the form that we write it in. So there we go. That's how you expand from vertex form to standard form. So my vertex here, if we wanted to tell you, would be 3, 1. Okay, remember the signs inside are backwards. And down here, the y-intercept would be 19. Okay? All right. If you're comfortable with this stuff, you can stop the video and keep going. I'm going to do one example that refreshes everything, and then we'll do a last example where we come up with the equation ourselves. Okay? So let's just go on to the next example. I'm not going to do all of them, just we're going to get an idea. I've got another quadratic function up here. It is in vertex form. So the first thing that we need to look at, or we're going to answer most of these questions, is it asks for the vertex. So I need to look at the h value and the k value. Now, when we're taking our h value, it's always the number inside the brackets, but the sign is opposite. So this is going to be a +1. The number out here is going to be a +4. Outside the brackets, the sign is the same. And it's only because our form for a vertex has a minus sign inside the brackets, so it changes the value, which is why when we pull the numbers out, we have to change the sign. Now, our axis of symmetry would go right through our vertex. Actually, before we answer these, let's kind of sketch this guy just a bit. We know my vertex is at +1, 4, so +1, 4. It's got this a value of 3. Now, if you remember from one of our first units, quadratics follow this step pattern, 1, 4, 9, 16, if you wanted to keep going. And if there is an a value, we know that it would be vertically stretched. So I can take my a value and multiply my step pattern. So 1 times 3 is 3. 4 times 3 is 12. 9 times 3 is 27. I don't need to put the rest of them down because there's no way they're going to fit on my graph. So really, I just need these two. So I'm going to go start at my vertex, and I'm going to go over 1 unit, and I'm going to go up 3. So I'm going to go over 1 and up 1, 2, 3. There it is. And then go back to the vertex. I'm going to go over 2 and up 12. Okay, I'm not going to bother because it's going to be so high it's off my graph. Then I'm going to go back to the vertex. I'm going to have to do it in the other direction. So over 1, up 1, 2, 3. And again, I'm not going to bother putting the other point because it would be so large or so high. I'm going to do my best to graph. It's not going to be a pretty parabola because we're using this kind of system to graph right now. But you should see that you get a kind of parabola. There we go. It doesn't look too horrible. And there we go. So now when we have to answer these questions, it should be a little bit easier. So axis of symmetry goes right through the vertex. The axis of symmetry would pass right through here. So it is x equals 1. It's a horrible x. Direction of the opening, because my a value is positive, it opens up. So this is up. Is it a maximum or a minimum? Well, because it opens up, it has a low point. So this is a minimum. It is a low value. Please do not worry about domain and range. Now, we're going to write it in standard form. We're going to determine the y-intercept, and then we're going to see if you could factor it to get the zeros. So let's determine our standard form. I'm going to go a little bit more quickly on this one. Okay, I'm not going to show you all of the steps. I'm going to combine a few of them, and I'm going to do all the math down at the bottom. Okay, so we were looking at g of x. There we go. So x minus 1 squared would be x minus 1 times x minus 1. When I expand those, there we go. When I expand the x minus 1 and x minus 1, I should get x squared. And if you don't believe me, that's okay. You're going to get x squared minus 2x plus 1. Okay. You can do that on your own if you don't believe my answer. Okay. Now I'm going to distribute the 3. Apparently not. There we go. Now we're going to distribute the 3. 3 times x squared is 3x squared. 3 times -2 is -6. And 3 times 1 is 3. So I've changed all the values inside my brackets. I've distributed the 3 to every term in here. And now I'm going to combine the 3 and the 4 to give me 7. 3 plus 4 is 7. Okay, so we've expanded. Done. We've done part H. Determine the y-intercept. This is the y-intercept. If I let the x coordinate equal 0 and I substitute it in for every x term, this term goes away, it vanishes, it becomes 0. This term becomes 0. Well, 0 minus 0 is 0, and I'm left with the 7. An easy way to do it, or an easy way to look at it, is just look at the last number in standard form. So you should get 7. We already have this beautiful graph. If you wanted to check your answer, look at my graph. It comes up and it did cross at exactly 7. So we know that the y-intercept is 7. Okay, we can write this as a coordinate 0, 7, and close your brackets. Okay, now is this factorable to find the zeros? You would need to find, you would have to guess and test because there is a value in front of the x squared. So this is a complex trinomial. I'm going to tell you now, you cannot factor this. Look at your graph. Your graph does not cross the x-axis, so you will not have any solutions or any zeros or roots or x-intercepts to this quadratic. So this is not factorable because of that graph, okay? And this comes into play later. Okay, so that's just kind of a refresher. It puts a few things together. And then finally, our last little question that I want to look at is being able to come up with a quadratic equation from a graph. So this is really similar to what you did last chapter, only this time we're using the vertex form. So look at your parabola. We want to be able to write something like this. If we need to turn it into standard form, then we'll just expand it afterwards. So looking at this, we know that the vertex is -3, -6. Okay, so given the following graph, the vertex, oh, perfect, we can write it in here. -3 and -6. And then we need another point. Now they tell us a point, they've given it to us, it's -1 and 2. If they don't give you a point, pick a nice point that you think crosses the grid nicely, like this one, that's probably your best bet. Somewhere where your grids cross, your parabola crosses on a grid, okay? So, but they gave us this one, so we'll use that. So we're going to take our vertex and we're going to substitute it in. And then we're going to take our point, since this is the x coordinate and this is the y coordinate, I'm going to take those and plug them in wherever I see x and y. Okay, remember, this is our h and this is our k. Okay, I know that looks like an x, it's supposed to be a k. So we can sub those in. The only variable that we don't know is a. By substituting this point in, we're going to solve for a. And then once we have a, we'll have our formula. Okay, I'm just going to set the bottom up a little bit different to give us more room. And then we will continue. Okay, I've shifted things around a bit for you. So hopefully now that we go to our solution, we have a little bit more room, we can fit it all on one page. So step 1, we are going to substitute h and k into our equation. So I've started with h and k here. There we go. And my h value is supposed to be -3. So I want to plug -3 in here. But when I subtract a negative sign, it becomes a positive sign. Okay? And my k value is -6. So I'm going to substitute -6 in for k. All right? So this is the h. It comes in here. This is the k. It comes down here. Now, I've got to figure out what my a value is, so I'm going to take my other point and plug it in for x and y. Now remember, f of x is just another way to write a y value, so that's really our y. Okay, so let's go back. We're going to copy this down one more time. And now this time, so step 1 would be substituting your vertex. Step 2 is substituting your point. So I'm going to plug in y equals 2, and I'm going to plug in x equals -1. Ideally, I would like you to put it into brackets, just so you don't get confused. It really won't make too much of a difference at this first step. Okay, and now we're just going to isolate for a. So let's do some algebra. -1 plus 3 is 2. Positive 2 squared is 4. So we're going to do that in one step. Okay, so -1 plus 3 is 2. Oh, maybe I'll do it in 2 steps. Okay, and then 2 squared is 4. Okay, now usually we just write the 4 in front of the a, but it's okay for now. Okay, now keep in mind this 4 is getting multiplied by a. So I have to get rid of the 6 before I get rid of the 4. I can't combine those two. So the -6, because it is being subtracted, when I bring it onto the other side, it has to be added. So this is going to be 2 plus 6. And then this 6 is going to vanish. 2 plus 6 is 8. You are left with 8 equals 4a. I have to get the a by itself, get rid of the 4. The 4 and the a are being multiplied. The opposite of multiplying is dividing. So divide to get 8 divided by 4, which hopefully 8 divided by 4 you know is 2. So a equals 2. And you've got your a value. So that was step 3, was solving for a. And now that I've got it, I can write it in vertex form. So I'm going to come back up here. I'm going to get my function. I'm going to take my h and plug it in. I'm going to take my k and plug it in. And then my a value we found to be 2 is going to be 2. And this is your vertex form of a quadratic. Okay, so from today, I can give you something in vertex form. You can simplify and expand, or expand and simplify to get it into standard form. And then when you have it in standard form, you can find your y-intercept. The other thing that you did today was looking at a graph, pull out your vertex, pull out another point, put them together, solve for a, and you can come up with your vertex form of a quadratic. All right, guys, thanks for listening and good luck. We'll see you tomorrow.